Hello and welcome to our presentation of ARRI wireless lens solutions. I'm Ian McCausland. In this video, I'll build a wireless lens system step by step, explaining the functionality of each component and its relationship to the entire camera build. We'll also look at some accessories that can make the job of focus pulling easier. The family of ARRI wireless products allows us to safely create content, whether it's for maintaining social distancing or based on the dynamics of a shot. The WCU4 is arguably the most widely used handset in the ARRI wireless family, and with good reason, because with the optional camera license installed, not only do you have full function over your lens axes, but you also have an extensive camera function menu as well. So let's go into the WCU4 and explore all of our options. The CForce motors can be daisy-chained together using a 4-pin connector called an LBUS. The LBUS connector provides power and communication between the CForce motors and the camera. One source of power and communication for the motors is from an LBUS connection located on the lens mount. ARRI provides lens mounts with an LBUS connection in LPL, PL, and EF. Let's look at how to build CForce mini motors on a camera. When building the CForce motors onto the camera, first we want to figure out where we want to place them. And with the ARRI accessories on this camera, I have lots of choices. I'm going to build the motors above the lens using this 19mm rod and the bracket on my down piece here. However, I also have the ability to do 15mm lightweight rods here or 19mm base plate spacing rods down here. The clamp console attaches to the support rods and holds the motor to the lens gear. The clamp console supports 19mm rods natively. Inserts are available for 15mm and 5/8 inch. In this example, I'm building with a 19mm support rod. ARRI has updated the clamp console to the clamp console 2. It can be used to mount CML5, CForce Mini, and CForce Mini RF motors, as well as the operator control unit or OCU1. With a motor installed on the support rod, I can now engage the motor gear into the gear on the lens. The gear on the CForce Mini motor can be attached on either side. This is a 0.8 or 32 pitch gear. It is the pitch that is used on cinema lenses. However, ARRI does provide different pitch gears for Panavision, Fuji, and Canon lenses. The CForce Mini motor can be built from over top the lens. In this build, the motors are close together to line up with the gears on this prime lens. It also frees up space below the lens for hand grips and accessories. With the motors installed, LBUS cables can be daisy-chained from the lens mount to the motors. When using 3 motors, it's recommended to use an extra power cable at the end of the chain. That would mean using an LBUS to DTAP or LBUS to RS, both of which are going to add additional power. When I power up the CForce Mini motor, you'll notice that this illuminates. Fizz stands for focus, iris, and zoom. And so to allocate which axis this motor is going to operate on, I'm going to press this setup button just above. And by pressing it, I now can allocate to focus, iris, or zoom. With the lens axis function established, it's now time to set up communication between the WCU4, the camera, and the motors. To establish communication between the WCU4 and the camera, let's make sure that the channels match. I'm going to go into Menu, and I'm going to navigate down to Radio Channel, Select, and I'm going to go down to Channel 4, Set, and the bars indicate that I now have a strong signal between WCU4 and camera. To establish communication with the handset, we have to turn on the communication within the camera. I'm in the ECS menu. I'm going to select it, and the first thing I want to do is go in and select my channel and make sure that I have the same channel selected in camera as I do on the WCU4. Next, I want to go up and make sure that my power is turned on for the radio. The CForce Mini motors will blink green and yellow. This sequence indicates that calibration is needed. Once communication between the WCU4 and the camera has been established, it will then request a calibration. If for some reason a motor needs to be recalibrated, pressing the setup button for 5 seconds will initiate a calibration. It eliminates the need to go into menus on the handset. In order for the WC4 and the camera to communicate, data about the lens must be transmitted. This can be done in several ways. The Alexa may have lens files stored internally in what is called the Lens Data Archive, or LDA. To access a lens file in the camera, we're going to go to the ECS menu and then into Lens Data. We're going to go in and look at something called the LDA, or Lens Data Archive. I'm going to select this, and I'm going to look at lens tables installed. I have installed this file previously from the WC4. And I'm going to go and I'm going to select my compact zoom 28 to 80, and we're going to select that. And now you can see just above it says lens table CPC 28 to 80. This will now populate information onto the WCU4. A focus scale style request may occur if you're using a Zeiss lens. The focus ring ID is 2 or 3 letters located on the focus ring. If there's no lens file in the lens data archive of the camera, then we'll need to build one manually. Here are the steps to build a lens file. The first step in creating a lens file in the WCU4 is we're going to open up the menu, and we want to scroll down to Lens Data. We're going to select that, and we want to go to Lens Programming. Select, and we're going to select Create a Lens File. I'm going to calibrate my motors. Now it wants me to select a brand. We're using a Zeiss. So I'm going to scroll down. I'm using the toggle right here that we use for the zoom. And I'm going to toggle down and select Zeiss. Next, it wants to know a type. This is a compact zoom, so I'm going to use the abbreviation CPZ. So again, I'm going to use my control, which is usually my rocker for my zoom control. And I've selected C, and I'm going to use the red button at the top of the WCU4 to make that selection. So I push in one time, and now I get a C. Now I'm going to go use the rocker to go down to P, and again down to Z. Now I can say OK, and you can see that I had 7 characters left, so I wanted to have more of a description there. Next, it wants to know, select a focal length. Well, this is a zoom lens, so again, we're going to take the rocker and hold it and go down to the very end where it says zoom and press OK. Now it wants a serial number. For the purposes of this example, I'm just going to call it 1, 2, 3. So I'm going to go up once, red button for number 1, red button for number 2, red button for number 3, and I have it selected, and OK. I want to use imperial as my measurement scale, so I click OK. Now it wants to know what axis I want to start working on. I'm going to start with the focus, and the first thing it wants me to do is it wants to have me roll the focus scale on the lens to infinity. And I'm going to line those up, and I'm going to click OK. So I've just entered the first reference point for the lens mapping. Now it wants me to go to my minimum focus. And on this lens, my minimum focus is going to be 2 feet 9 inches. So I rolled to 2.9. Now notice it says 2 feet here. Well, again, I'm going to use my rocker to go up to 2 feet 9 inches. And I press the red button. Now it's a question of moving my focus ring here, and I'm going to go to the next focus mark on lens scale, which is 3 feet. Sometimes these numbers are going to line up, sometimes they are not. In this case, it's not at 3 feet, so I'm going to just click up to 3 feet, hit the red button, And so part of the process of creating the lens file is going through now to every focus mark on your lens, rolling with your focus knob here, and then checking to make sure that the data entered for the set is correct, and then hitting the red button. We're at 50 feet. I'm going to push the red button and mark it. And now I'm going to go to my last mark on the scale, which is 100 feet. And I'm going to go up to 100 feet. If I hold down on this, the speed starts to accelerate. I have 100, my red button. Now I have all my focus marks on the focus scale completed. Now I can push the finish button up here at the top. And it's asking me to confirm that I have completed my focus. I'm going to click OK. I'm ready to move on to my next axis, so I'm going to choose the zoom axis now. The zoom axis is being controlled right now by this slider. So what I'm going to do is I'm going to do the same procedure that I did for the focus, where I'm going to go up to 28. And I'll push the red button, and I'm going to go to the scaling on the zoom ring and mark each increment on this scale. I have my zoom scale here. The last one I need to do is 80. So I'm going to take my slider and move it all the way to the top. And now I'm going to use my zoom stick. I also call it a rocker. Some ACs call it a rocker. And I'm going to go down till I get to 80, hit the red button, and I am completed. And it's asking me if I want to do any more work. I am completed, so now I'm going to click OK. That leaves one more axis to do, which is our iris. And I'm going to use the slider to set my T-stops. All right, so we are at T16. Now we're going to go to T22, slider all the way down. It says set 22. I hit my red button and asked to confirm with OK. Great. All right, so now everything has been done. Now we need to save the file. The file is saved on an SD card that is loaded to the WCU4, and that is formatted as FAT16 or FAT32, and you want to use no larger than a 16 gig card there. Notice at the top it says save, so I'm going to push the button one time. And what this is allowing me to do right now is it's got into an edit mode. If there is an attribute that I want to go in and change, now's the time I could do it. Notice that the cursor is flashing on the Zeiss. But I like everything I have here, so I'm going to go ahead and hit save one more time. Asking me if I want to do another lens. I do not, so I'm going to select no. Now here's where things start to get a little confusing, because we just went through all this work to save all that lens data. We saved it to an SD card, but there's no information on the LCD screen. And this can be a little frightening, because at this point you might think, what happened? Well, actually everything's fine. You just need to be able to send that information over to the camera. To do that, I'm going to do what's called a lens file transfer. And to do that, I'm going to go to Menu, and I'm going to go down to my lens data, select, and I'm going to do something called a lens file transfer. I'm going to select it, and you see I have a couple of lenses in here, and I'm going to scroll down to my compact zoom 28 to 80, and I'm going to select it. Now I'm going to send that information, which will now load it into the lens data archive on the camera. Now that that's done, I'm going to go home, and after a calibration, Now we can see our data displayed on the screen. So I can open the iris to T29, I can change my focus, but I want to do one more thing, and that is I want to have a hard scale on the side here so I can make a comparison of my scale to the footage marks I have on my focus knob here. So notice that I have a focus readout in the center. I have a focus readout with my pointer right here. And now I'm going to add a hard scale. Now when you put a scale on here, there is a little locating pin right here. And there is a little recess on that scale to line it up. Now there's a couple different ways that you can approach this. Let me put this on here so we can take a look at it. Now notice this little box right here. This box says 3 feet 6 inches. And if you go down and you notice that the close focus on this lens is 2 feet 9 inches. So why did I select those? Well, if I know that I'm not going to be working at a distance for the subject to be closer than 3 feet 6 inches away, the advantage of using the scale is that the marks are further apart. So it gives me a little further throw here. Now the problem is that now there's a discrepancy between the focus mark here, the focus mark here, and the focus mark on my scale. And the reason that that's occurring is because I have not told the WCU4 what focus scale I'm using. So to tell it that, I'm going to go into the menu and I'm going to go to the first item, which is pre-marked focus ring, and I'm going to select that. And in here, you're going to see a selection of pre-made scales available. And I'm going to go down and I'm going to select 3 feet 6 inches and set it. And when I do that, now look what happens. Immediately, all my focus marks line up. Now that we have our data displayed on our screen, let's go in and look at some menus that will make our task of pulling focus a little easier. First thing we're going to do is go into menu, and I want to go down to motor setup. The first one in here is pretty important, the torque setting. I hit select. Notice that I have different numbers assigned to the different lens axes. If you are pulling focus or zooming or even changing your T-stop and you notice a little flex in the support rod, particularly when the ring gets to the end of its travel, you may have too much torque applied to that motor. Well, here we can come in and we can, with the axes selected, we can now go in and we can change that number. This is the side selection. This is more of a preference, but what this means is what is the orientation, or which side is the motor on the camera from the operator's point of view. And last we have teeth, and it's an automatic. So this has been selected for us when we did our setup. Going back to home, let's go in and look at a menu called Control Setup. Now, the reason I want to go in there is notice the slider for my iris on the left-hand side here. Notice that the slider at the top position is at T29, and if I slide down, I'm going to T22 on my lens. But what if I have a preference of, I want that reversed? In other words, as I slide up, I want to close down on the lens. Well, if I want to do that, I can go into the menu, and I'm going to go to the Control Setup, select, and notice at the bottom I have the slider, the stick, and I have the knob. I'm going to go into my slider, and I'm going to go down to the reverse direction command, and I'm going to change that to on. When I do that, now T29 is at the bottom, and as I slide up, I'm closing down on the lens. Now that we have our lens file all set up and we have our data on screen here, let's go and look at a couple of features inside the menu that can assist us for focus. Now notice I have iris, zoom, and focus buttons active down here, or they can be active if I push them. And what these do is set limits. I'm going to show you how to set limits and markers in the focus, but we can do the same thing in the other two axes as well. So to access those features, I'm going to press on the focus button, and I have at the top something that says marker. And marker, as the name implies, means that I'm able to put marks on different focus points. So I'm going to go in here and I'm going to go into marker, and I'm going to mark 10 feet, and I'll go to 8 feet and I'll mark that. So now I have my focus marks from 8 to 10 feet, and might be able to pick this up on the audio. As I roll over these, there's a slight tone that you hear, and there's also a vibration. Now the nice thing about this is that you can be hitting your focus marks, but if your talent goes off their marks, you still have the range to adjust for them. And you can go in here, and if I need to reset, let's say I want to reset from 10 feet, I'm going to hover over it, hit reset, and maybe I'm going to extend focus now to 12 feet. And I'm going to mark, and there it is. Now I'm going to remove these, reset. Now let's talk about some other features in here. Let's talk about your limits. Now with the focus limit, let's say you have a shot where it's going to be a predictable move every single time. So hypothetically, let's say that we're going to start our focus at 6 feet, and we're going to always finish focus at 10 feet. Well, I'm going to set 6 feet, and I'm going to hold down on the limit button, and I'm going to roll to 10 feet, and I'm going to let go. Now you can see that the whole scale is just those marks that I've limited. So I'm going from 6 feet to 10 feet. And if I want to get rid of those, go back to my default. Notice it illuminated blue, and that means it's active. If I push that button again, it goes away. Now I have my full scale back. Now let's talk about K limit or knob limit. Let's think about a situation when you're shooting that this is really helpful. I'm going to roll to infinity, and if I want to go to close focus on this lens, I'm going to say that this focus knob rotation is about 360 degrees. But let's say you're going to have a shot where the action is going to happen very quickly, and you have to do, say, a whip pan, meaning that I have to go from one point of focus to another point of focus very rapidly, and by manually doing it, I won't be able to keep up with the action. So what I want to do is I want to reduce the physical turn to get from infinity to close focus. So if I want to do that, I'm going to press on the K limit or knob limit. I'm going to hold down on this, and I'm going to roll down to about halfway. And now what happens is when I turn a quarter of a turn now, I am now changing that focus very rapidly. If you've ever used a mechanical focus, like a studio focus, for example, this is the same effect as if you'd put a speed crank onto one of the focus knobs. It just allows you to cover a much greater distance of focus on the focus barrel rapidly. Again, if I want to get rid of it, I simply push the button again and get rid of the blue highlight. And the last one over here is offset. Where offset comes into play is if for some reason you line up, let's take 15 feet here. Now it's lining up fine on the lens, but if there was some circumstance where there was a slight offset between the physical marks on the lens and the scale here on my WCU4, I could push in on the offset, and I could turn slightly, get them to line up, and now I would have a focus alignment that was proper. I'm going to turn that off, and now my focus goes back to 15 feet. What if you're working with an Alexa without an LBUS connection or another brand of camera? That's where the CForce Mini RF motor comes into play. The RF motors have a white radio module installed in them. It allows us to connect to the WCU4 handset, but we can also connect to other types of ARRI handsets as well. This allows us to split focus, iris, and zoom to 3 independent handsets and have discrete control of each axis. The RF motor has a display and 2 soft buttons for setting motor axes, activating a motor calibration, and selecting one of 14 radio channels. The LBUS connector allows for up to 2 additional CForce motors. The CAM connector provides power and run-stop camera control for ARRI, Red, Sony, and Blackmagic cameras. With an RF motor installed, we have other accessory options. For instance, if we add an L-Cube1, it now allows us to use the UDM1. The UDM1 is the Ultrasonic Measuring Device Unit, and it gives the focus puller real-time updates as to the subject's distance to the focus plane. Now, the unique thing about this is that the display can be removed from the horns, and the brain will retain, in the horns, will retain the data such as offset. With the UDM active, you can now see in green, I have the readout from the sensor, which allows me to now roll my focus in and be exactly dead on. Also notice that the arrows line up on my scale. What if you're on a shoot and the DIT wants control of the iris? Well, with the SXU1 or a single axis unit, that can be done because we can set the channel of the SXU to the same channel as the WCU4. And that's what I've done on this unit here. I went into the WCU4 and I turned off the slider for iris, and I made that iris now the knob on the SXU1. Suppose a shot calls for handheld operation. In addition, the operator wants to be able to temporarily pull focus or have zoom control. The ARRI Master Grips not only provide a handheld grip solution, but incorporate controls that allow for a host of lens and camera operations. Master Grips have 6 programmable user buttons on each grip for a total of 12. The functions of these buttons can be configured in the camera body, and they can control such functions as white balance, ISO, and ND filters. In multicam applications, you could program user buttons to toggle return video and for intercom. Master Grips are connected to the camera via LBUS cables. Master Grips come in 4 styles. A rocker style, which is available in right and left and are ideal for zooming. This is the thumb wheel style of Master Grip, which is available in right and left. This is the left-hand grip, and it is ideal for focus pulls. Master Grips can be programmed with numerous functions. In this example, I'm going to show you something called override. Notice our status right now is that our thumb wheel here is set to focus, but it says no control. And if I turn the thumb wheel, in fact, I have no effect on focus. So I want to set up a user button so that I can do that. So I'm going to scroll or swipe once, and in the center where it says off, I'm going to hold for a couple of seconds, and this will show me a sub-level menu. Now I could program user buttons, but I want to go up to something called override. There's override. I'm going to tap once. Now that is selected, I'm going to go back, and now it still says no control, but now when I push on my button here, now you can see I now have focus demand. Now I have just taken that from the WCU4. If I want my focus puller to take focus back over, I simply push in again, and now the WCU4 has focus control. The WCU4 screen will turn red when it has been overridden by a Master Grip. The OCU1 stands for Operator Control Unit. The compact size of the unit makes it ideal when you want to take control of one lens axis. A common use for the OCU1 is to take control of focus from the WCU4. And the OCU1 has dual LBUS connections, and that allows for numerous configurations with the appropriate cable. To assign focus to the OCU1, first I need to go into the Axis menu and assign focus. To do that, I'm going to hold down on this menu for a couple of seconds, and it takes me to Axis. I'm going to tap one time to open that menu, and I'm going to select focus. Tapping will select it. Now I'm going to swipe and go back. Now you see that I have focus, but I don't have control. So I have put an override command into one of my user buttons. And when I do that, now I have control, meaning that the WCU4 no longer has control of focus. I click on my user button again, and now the handset has focus back again. The EMC1 allows use of ENG-style cine servo zoom lenses with the connectivity to ARRI handsets. The EMC1 or ENG motor control has a Hirose connector that accommodates standard ENG servo zoom lenses. Each axis of the servo zoom can be handled via the WCU4 or a single axis such as the SXU1. This gives the operator the freedom to compose while the AC has control of focus. Once the power cable is connected to the EMC1, the unit will power up. There is no on and off switch. Press the lens soft button on the home screen to enter the lens menu. Depending on the lens you're using, it will be possible to toggle between metric and imperial measurements. Pressing the radio soft button permits changing of channel to match that of the WCU4. Once connected, lens data will be transmitted to the WCU4. The ultrasonic distance measure, or UDM1, is comprised of two components. The horns of the UDM1 detect the distance of an object. What makes the UDM1 unique is that the brain is located in the horns. That means that the display panel is not required for its operation. Once information from the horns is collected, it is then passed on to the LED display. If I attach the L-Cube1 to the camera, it's this component right here, data from the UDM1 opens up new possibilities. Currently, it's imperative to practice social distancing while on set. The ERM2400 LCS stands for External Radio Module, and these modules allow us to extend the use of our handsets up to 3,000 feet away. This not only gives us a great flexibility for social distancing, it also provides a safe environment for challenging shots such as between vehicles. ERM units are paired at the factory. The only setting to be checked is that the serial numbers match, and the serial number is located on the side of the unit. With the ERM, the first thing I'm going to do is power it up. I'm going from a 2-pin connector to a D-tap on my camera. That powers it up. Next thing I want to do is I need to establish communication with my motor. So I'm going to use a cable that goes from a CAM connector, which is a 4-pin, to LBUS. So as soon as I push that in, it now finds it. You can see that my signals are strong, all my data is present. I'm ready to go to work. The ERM operates at a frequency of 2.4 gigahertz. It employs frequency hopping to eliminate the possibility of other wireless devices interfering with communication. Frequency hopping looks for spectrums within this bandwidth to maintain uninterrupted communication. Now that I have the ERM installed on the camera and I have an ERM at my WCU4, I now have wireless connectivity over a long distance with camera operations and focus. I want to take it outside and be socially distant from our talent, and I'll be able to monitor the image because I am using ARRI's wireless video system. The UMC4 or Universal Motor Controller handles up to 3 motor axes, and I can control them independently with 3 handsets. It also has some unique features built into it. The UMC4 incorporates the LDS Lens Data Archive and generates frame-accurate lens data with any lens. Lens data is used for lens mapping to pre-marked focus rings and depth of field display on the WCU4. The UMC4 supports internal and external timecode that is recorded with frame-accurate lens data onto SD card, making the lens data usable for post-production. The internal timecode clock can be jam-synced from external devices, but can output LTC timecode as well. The UMC4 includes multiple interfaces. 2 serial interfaces connect peripheral equipment such as ARRI UDM1 distance measure. Optional connector modules can be swapped to interface directly with focus and zoom demands from Fuji and Canon. That wraps up our look at ARRI wireless lens solutions. We hope that this has been informative and instructive. Thank you for joining us.